All right, so hello everybody. So video lecture number 3, and today we're gonna be talking about the planar rigid body motion. All right, so as we have done in other weeks, today we're just gonna do 3 problems, and then I will assign you a problem and some theoretical questions. So we're gonna start with this problem number 1. This is a pretty popular type of problem where we are given some rods connected to a piston and to a link. So for this problem, we're gonna have this element, then this element 2. The piston right here will be element 3, and we're gonna call the pin position A, B, and C. So we're gonna get started, but first let's see what we need to do here. So for problem number 1, the velocity of the slider block C is 10 feet per second. So that's given right here, and it's also given the direction of that velocity. Determine the angular velocity of link AB, so AB, element 1, okay, and BC, element 2. And the velocity of point B at the instant shown. Okay. Alright, and the velocity of point B. Okay, so what we're gonna do, we're gonna start writing our equations for relative motion, and since we need to calculate the velocity of point B, I'm gonna calculate that as the velocity of point A plus the velocity of B respect A. Okay, so we can actually analyze a little bit this equation right here. Point A is pinned right here. So what we can see is that the point A is not gonna translate. It's not gonna move, right? It's gonna rotate. So element 1 is gonna rotate about point A, but point A is not gonna move. So the element is not gonna just like move, from here to here. That's not gonna happen. So that's why the velocity of point A is equal to 0 feet per second. So we can say that the velocity of B is equal to the velocity of B respect A, and the velocity of B respect A is gonna be equal to omega AB cross product RAB. And that's a vectorial equation. Okay, so let's actually go ahead and highlight that. Okay, so do we know RAB? Yes, we do. It's 1 right here. Do we know omega? No, we don't know that. We need to find that. And we don't know VB. So what we're gonna do next, we're gonna write a new equation. So I'm gonna calculate VC. Let me see, I need to calculate BC. Actually, I'm gonna write the equations of relative motion for point B, but now I'm gonna do it respect point C. So I'm gonna calculate the velocity of B respect point C. and those like this is my equation. Okay, now let's see. Do I know VC? We do. That's 10 feet per second. Okay, and we don't know VBC, but we know that that's gonna be omega BC cross product RBC. Well, so right now we get this other equation. I'm not totally going to highlight that. Okay, now what I'm gonna do, I'm just gonna call this one 2 and this one right here, so this one 1. So I'm gonna solve for B. Then what I'm gonna say is basically 1 is equal to 2. So we're gonna have omega AB cross product RB equal, and here we're gonna have VC plus omega BC cross product RBC. Okay, now we have a vectorial equation in 2D in the X and the Y, and we have two unknowns, and those are omega AB and omega BC. We know the rest of the variables in this problem. So what I'm going to do, I'm going to decompose these equations in the X and in the Y. So let's do it in the X. Actually, I'm gonna go ahead and I'm going to solve for this vectorial product, and that's probably gonna let me decompose my equation a little bit better. So we're gonna have I, J, K, 0, 0, omega AB is gonna be gonna write it omega AB in the K, and I'm gonna assume this is gonna be negative because this potentially will rotate like that, and this member element 2 will rotate like that. Okay, so that's gonna be negative, and then we're gonna have the position from A to B. It's gonna be 1 positive in the J. Alright, that's gonna be equal to VC can be decomposed. We have this 45 degrees angle right there. So that's gonna be, let's see, actually I'm just gonna go ahead here. That's gonna be 10 feet per second times cosine 45, that will be in the I, plus sine 45 degrees in the J. So let me write my sign convention. This is gonna be my positives. This is the I, J, and then using our right hand rule, that's gonna be positive moment in the K. Okay, so now we're gonna have here 10 feet per second times cosine of 45 degrees I plus sine 45 degrees J. And finally, let's see if I can, okay, there we go. And finally, we also have the cross product, which is gonna be 0, 0 omega B C, because I assume omega B C to go counterclockwise, which is positive, and then we're gonna have positive, well, actually this is gonna be from C to B, it's gonna be -1 R B C. Actually, let me see, R B C, no, that's gonna be positive, right, from B to C. All right, so that's gonna be 1, 0, 1, but that's gonna be in the I. There we go. Okay, I need to solve for this, and just gonna do it right here. So for the first term here, we're gonna have omega A B I positive, and for the second cross product, we're gonna have, see, it's gonna be positive as well, omega B C J. Okay, now we can go ahead and try to solve for these equations. Like I said, now I'm gonna decompose in the I or X and in the J or Y. So I'm gonna have omega AB equal 10 feet cosine of 45. And then omega BC equal 10 feet per second. There we go. Sine 45 degrees. All right. Whatever this is, we're gonna have that omega AB is equal to omega BC. But I'm just gonna go ahead and calculate it. So it's gonna be 10 times cosine of 45. That's 7.07 radians per second. The units are always super important. There we go. And now, if I want to calculate VB, and we want to, let's see. If we want to calculate VB, we can go back to my equation number 1, and I can say VB is equal to omega A B cross product RAB. So I go ahead, I do my cross product again. I did this, but just gonna go and do it again because now I know that my omega AB, which is actually, let me go back here, and so omega AB and omega BC, I assumed omega AB to go clockwise, correct? Yeah, that was my assumption right there. And I got a positive number, which means my assumption was correct. Now, for my omega BC, I assumed it to be counterclockwise, and I got it positive, so my assumption was right. Just like that. And now I'm just gonna actually I'm gonna highlight that this is my result. Try to, there we go. Okay, Now, so I need to write this back here, but it's gonna be negative because it's clockwise, and that's my omega AB. Then I multiply that by 0, 1, and 0. That's gonna be 1 feet given in the problem. So basically RAB. Okay, so I solve for this, and if we do that, we're gonna have. I need to actually. Okay, I think it's gonna be positive 7.07 meters per second. Feet per second. Okay, there we go. All right, so this is gonna be my VB. Just gonna highlight it as well. Okay, so now we got this result. I kinda want to come back here, draw the problem, and analyze those velocities. I wanna make sure that those make sense for the system that is given in this problem at the instant shown. Okay, so my angular velocities omega AB and omega BC are in red right there. And if I want to analyze my velocity at point B, I'm gonna do that in blue. Well, let me say A, B, and C. My velocity right here is just like that. Okay, it's gonna be VB. So I need to come back here and fix this because this is gonna be in the eye. Okay, so if you solve, I'm gonna make this a little bit. All right, in the eye. So if you solve this cross product, you're gonna have 7.07 feet per second in the eye direction. And that makes sense at this given instant because the velocity is positive just in the I direction, and it makes sense it's going in that direction because omega AB is clockwise, and also you can tell that the path of this rod, if this thing is, if element 1 right here, or element AB is spinning about point A, the path is going to be circular respect that point. And that point right there, the velocity is going to be the tangential to that circular path. And that's what we obtained. So that makes sense. Okay, so first problem is done, and I think we're gonna go ahead and start with the second problem. Okay, so for this problem we are also given a system, and this system is composed by a flywheel A that is rotating about point O, attached to a rod at point B, and this rod is also attached to a point to another rod at point C, and this other rod is attached to a pin at point D, and that one is constrained in translation right there, as it is point O. Okay, So we know that the angular velocity is clockwise, and it is 6 radians per second for the flywheel A. And we need to determine the angular velocity of the rod BC at the instant shown. So BC, this is my rod BC, and I need to calculate the angular velocity. So let's see. This thing, uh, so the flywheel, it's gonna be rotating clockwise. So we're gonna have a velocity. I'm just doing a quick analysis of the problem. So we're gonna have a velocity that is going like that. It's gonna be VB, right? Now, at this specific instant, okay. Now, I think we're gonna have a velocity just like that, which is gonna be VC. So to me, the angular velocity of BC is gonna be counterclockwise. So that might be a little bit hard to see. So if you don't see that, that's okay. You can give a polite guess, but if you weren't right um, at the first time that you gave a guess, that's okay, because when you get the final answer, you will get it negative, and that means that it's just going in the opposite direction. Okay, so let's get started, and let's see what we're gonna do here. So we're gonna use the relative velocity equations again. So we're gonna start with VB is equal to VA, and I'm gonna actually call it V naught plus VB respect naught. Okay. All right. So for this specific case, we can go ahead and solve, right? Because we know that V naught, the velocity at that point right there, it's is equal to 0, because that point right there is not translating. So finally we're gonna have VB respect 0.0, and that's gonna be omega A, the angular velocity of element A, cross product this distance right here from O to B. Okay, so we can do our cross products again, but also if you want, we can actually multiply this length times this angular velocity, and that's gonna give us a VB that goes just like that. So my sign convention is gonna be the same as we used in the other problem, the previous problem. I always use the same sign convention, and let's see. Actually, let's do the cross product, but I think this is what we are gonna get. Okay. All right. So we are gonna have I, J, K, 0, 0. This is gonna be negative 6 radians per second, and then the position, it's gonna go from O to B, and I expect that to be negative 0.3 in the J, right? So we saw for this cross product, and let's see, this is gonna give us a negative okay, so that's gonna be a negative, and I need to find the answer. I should have it somewhere here. It's gonna be negative 1.8 in the I meters per second, and that's what we expected, right? That velocity right there. Okay, so that just gave me the velocity of VB. We still need to find omega BC. So what we're gonna do next, I'm gonna calculate VC using VB. So there we go. All right, so we know VB, we just got it from here. We know, I'm gonna give myself some extra room. Maybe if my computer doesn't crash. Okay, well, okay, so, and then I don't know VC respect B, but I know that that's gonna be omega CB. Actually, maybe BC. Okay. Okay. So we're gonna have yeah, that doesn't really matter. So we're gonna have CB cross product CB. Now from B to C. Okay. I need to check something. Just need to double check. Just a second. Okay, yeah, I think that's fine. All right, and then what I'm gonna do next, I'm going to calculate point C, but now I'm gonna calculate it using point D. So that's gonna be VC equal VD plus VCD. And again, this is gonna be omega CD cross product DC. And now what I'm going to do, I'm just gonna make these two terms equal. So I will end up having two equations, two unknowns. Let's see. So we're gonna have VB plus IJK 0, 0 omega CB. I assumed it to be positive, so it's gonna be omega CD, and then we're gonna have positive, what is that, 1.5 in the I, so it's gonna be 1.5, 0 and 0, and I close right there. Okay, that's the first part. Now actually I'm gonna go ahead and substitute for VB. Okay, that's the first term, and that's equal to this, right? So that's gonna be VD how much is VD? VD is equal to 0 because this point right here is not translating, so that's good. And then we're gonna have I, J, K, and let's see, we're gonna have 0, 0. If this thing, if omega BC is rotating counterclockwise, I assume that, let me see, okay, I assume that omega DC is also rotating counterclockwise, which is positive. It's gonna be omega CD. Alright. And then we have the distance from D to C, and that's gonna be in the X component, it's gonna be 0.6 cosine of 60 degrees. So I'll try to make that smaller because I'm not gonna have room. Okay, cosine of 60 degrees, and then it's gonna be sine 60 and 0 in the Z or K component. Okay, let's see if I got it back. Oh, there we go. Okay, so now you can see that we're gonna have two unknowns, omega CD and omega, it's gonna be CB. CB. Okay, omega CB and omega CD. So let's go ahead and solve for this. Cross product. And here from the first one, I'm going to have 1.5 omega CB. I think, let me check again, that's gonna be J. There we go. And for the second one, we are gonna have 0.6 cosine of 60 degrees. Let me see, I need to double check. Okay, that's gonna be omega CD and then J. Need to double check, just make sure I'm getting, okay. And then that's gonna be minus, I need to see, 0.6 sine of 60 degrees omega CDI. I think that's correct. Okay, now as we did before, we are going to decompose in the I and in the J. So we're gonna have in the I, we're gonna have minus 1.8 I equal this guy right here, minus 0.6 sine 60 degrees omega CDI. Okay, that's nice because now we have one equation, one unknown. Okay, let's see what's happened with the second one. For the second one, we're gonna have 1.5 omega CBJ equal 0.6 cosine of 60 degrees omega CDJ. Okay, two things that I can tell at this point. First of all, J cancel out, I and I cancel out, minus and minus cancel out right there, and I can tell that my sign convention, not my sign convention, like my sign assumption at the beginning of the problem was right, because my omega CD and my omega CB, they are gonna be positive, so that means like my assumptions were correct. Okay, now we need to go ahead, solve for this from the first equation. just gonna go ahead and actually solve it with my calculator. Make sure that I'm doing this right. 6 times sine of 60 degrees. Okay. Alright, so the first one is correct. Okay. Is 3.46 radians per second in the K, right? And then once I got that, I can solve for my omega CB, which is actually what I needed, right? Yeah, I'm just gonna probably go ahead and write my K here, but yeah, okay, there we go. So my omega CB is gonna be 0.693. Again, in the K radians per second. And that's what I was trying to solve. All right. So this is it. Hopefully it's straightforward. As takeaway, I will, highlight the fact that when you are given a system just like that, you can always start solving those velocities that you need, or like how to solve. For this problem, we could solve VB pretty straightforward, using the relative velocity equation. So remember, we did VB equal V naught plus VB respect naught. That was very straightforward. And then what we did, in order to get more equations and to get some equations that we can use to solve for what we were asked for, we escalated and we kept solving for VC, since we knew VB, and then we just used the relative. Okay, this is not writing at all. There you go. Okay, so we solved for VC, since we knew VB, and we could find omega BC times the length of position C. So that's how I would solve this type of problems. And well, so I think this is all we got for today. Bye.